Hello, Professor. Thank you for your time in listening to this report. And this assignment survey was directed by Kanjo-sang, and it's following up the request from Minister of Mongolian Education and Science Ministry. And let's see it. And the reason behind the request was due to these facts, and not only in this Sustainable Development Vision 2030, but every governments have been tempted to diversify the economic income by fostering manufacture of the products, because up to date the output of the mine has been dominant in the budget composition, and it's worthy to mention that mostly these resources are just exported without any further processing, which means they are being exported with the lowest possible value and price. This is just one of the many reasons behind it, and such as both quantity and the quality of engineering and scientific graduates just don't meet the employer's criteria and so on. Unfortunately, on the other hand, the number of university students choosing their major in engineering, math, and computer and science are decreasing over the past decade, and even the number of math, computer, and science are remain quite low throughout the years, and therefore both quality and quantity of the STEM workforce are needed to be increased, and we have to work on it. And we believe that there are three steps for a student to choose their major in the aforementioned field and be capable of it. It's proficiency, information, and the passion. First of all, they must perform well in that field, and it can be achieved with a well-written curriculum based on intensive research data by the professionals, and obviously the both skill and attitude of the respective teacher, and very importantly the classroom environment and implements laboratories and its equipment for a case of STEM. And secondly, the students have to be informed about what majors requires STEM knowledge and how those knowledge could make a final product, and the beauty of manufacturing, how do they can solve the economic and environmental problems faced by the society, etc. And in this stage, all the government, schooling institute, parents, and professionals, as well as the private enterprise and the corporate, should collaborate together. And finally, if the students gain the high quality knowledge and were informed properly, it's just a matter of time, depending on the student's individual characteristic, to choose the major in that field and be competent graduate in that field. And to sum up, we are focusing on this part only: the classroom environment and implements, aka laboratory for physics and chemistry. Okay, and we have tried to list the benefits of doing hands-on experiments, and they're it's effective, more digestible, and easier to remember the completely new concepts right afterwards the class if the students have involved their hands and seen the results rather than just listening. And we believe it's dexterous, and since the procedure has major influence on the final result, they will learn to be attentive and gain more control over their hands and be a bit careful while doing other stuff. And it's a student-centered teaching practice, means instead of a teacher, they will make assumptions prior to the experiment and observe the phenomena and ultimately analyze the data that have been obtained. And it's a teamwork. They will be asked to collaborate for a mutual objective, and therefore the communication during the data comparison and final result processing will teach them about the soft skill essentials. And the last but not least, they will be seeking for the information to proceed to gain the knowledge instead of directly receiving processed information. And here, this graph from the Program of International Student Assessment 2015 also supports our idea that the experiment will boost science-related attitude of the students dramatically, and it shows three different types of teaching practices. And the first one, teacher directed. It usually includes teacher explanation and students' question, and the adaptive instruction refers to teachers' flexibility to tailoring to their students' need. And the last one, the inquiry-based practice aims to engage students in experimentation and hands-on activities, and it's all about communication and collaboration. And you can see clearly how students' attitude towards science can vary dramatically and in three different types of practices. And yeah, okay, for your information, in Mongolia we have secondary education starts right after 6 years of primary education and is followed by the higher education. And there are over 300,000 students are taking physics and chemistry classes, and it means this issue covers more than 90% of our first and secondary schools. And in the first round of survey, which had more flexible and simple questions, and we surveyed over 700 teachers in order to pinpoint the problems. And for the second round, which had more detailed and it's dedicated for the data collection, and it was from 1,107 teachers. And as a result, as you can see from here, we have obviously lost the gender equity in both chemistry and physics teachers. And about the administration, we do have an education bureau in 9 districts of the capital city and as well as in the 21 provinces. And they aim to provide educational services and monitor the implementation of the policy. And within this bureau, each subject, such as like math, physics, English, literature, geography, they do have a corresponding specialist. Unfortunately, there are 8 provinces have no chemical and biology specialist, and 14 provinces are now without any physics specialist. Okay, so how do they cope with this situation? And here's an example of one province named Hinti, and she has a chemistry degree and hired as a chemistry specialist at first. However, due to the lack of employees, now she is responsible for obviously the chemistry and biology and geography, health, physics, as well as the education for sustainable development. And so we have to improve the management unit in order to have better policy implementation speed and better data for policy making. And okay, since this presentation is for people who has no deep understanding about the physics and chemistry, we try to provide general understanding about the laboratories. And as we said before, doing experiment is as much as important as learning the single theory. And in general, to do a physics experiment, we need a main instrument, and it's same as the ones we had in 2013 and 2015 from Taiwan, and as well as the other supplies such as wire, resistor, battery, etc. And for a chemical laboratory, it's a bit more complex, and there are glassware. We have provided only 200 schools out of more than 700 in those years. And chemicals and equipment and furniture, for example, sink, water distiller, and fume box, etc. And last but not least, the other supplies such as filter paper and indicator, single-use gloves, etc., which run out of very quickly, just like a tissue in the office room. And okay, the results section begins. Firstly, we try to identify the percentage of the physics equipment usage precisely, and as a result, depending on the type, it was around between 40 to 60%. And for further, we clarify the reason why they are not using those equipment, and teachers claim the following reasons. And as you can see from here, the biggest reason was sufficiency, and because this equipment is not for teachers to use and demonstrate in front of like 40, 30 students, but just for the students to work as a partner and to experiment. However, in those years, only one equipment from 10 types had allocated in 200 schools. And the second biggest reason was in the province was the fact that they can't use it. Followed by there is no time for it. It's quite obvious because they don't have they don't have a laboratory time, and the time is only 40 minutes in each session. And if they want to try to do experiment, they have to bring it to the classroom at first and install, do the experiment, collect and process the data and report it, etc. And it's impossible for one teacher to do everything in front of so many students. And the last two reasons are mostly because of there are no specific room as a laboratory to keep the equipment safe and use them in it. And those are the last two reasons. And interestingly, the fact that they can't use the equipment wasn't the second biggest reason in the capital city, but the time, there was no time for it, was the second biggest reason. And about this one, the gray one is, yes, there's no problem with it, and gray one was for some reason not. Oh, I forgot to tell it. Okay, so since we had opportunity to collect contact information of more than 1,000 teachers, using this opportunity, we asked every physics teacher whether they need those newly launched products of SF Scientific Taiwan. And this basil kind of dark gray shows the teachers said it is needed for the students, and this fern kind of bright red is the teachers who are not sure about it, and the red represents the teachers are against of it. And we also asked how many equipment from each type should be in the one school, and the results are here. And for the next part, we asked teachers whether these 33 types of glasswares are necessary for them. And this dark green represents the teachers who had received the investment in 2013 and 15, and the gray one represents the rest of the teachers who didn't receive the investment in those years. And from here you can see that all the teachers, they do have glasswares to some extent, but more fragile glasses must be repurchased more frequently, like not just once in 5 or 6 years. And moreover, they received chemical models for assembling particular structures like fullerene, ice, diamond, and something like that. And the results are the quite same with capital and the provinces. And from here, the fullerene is relatively low in both places, and we assume it's because teachers thought it's more suitable for like university level rather than secondary schools. And just to remind you, the chemistry laboratory needs more than just a single glassware, and therefore we asked from over 500 teachers about the other facility, and they claim, as shown, and about the equipment and the furniture, they have nothing. 2 feet need more, and the yellow one shows only the essentials but need more, and the green ones say they are sufficiently enough. And about the chemicals, it's worse, and the sufficient amount is less than anyone else, and the other supplies were even worse than rest of them. And yeah, that was the result. And we also took account of the other factors, and namely specific laboratory rooms, technical assistant, and the time per week. And we asked every physics and chemistry teachers about their opinion on these matters, and they responded as shown. And about the specific room as a laboratory, and most of them said it's needed to be established. And the green one says we do have now, so we don't need it, but we do use it and we do have it. And the black one said they don't need it at all. Maybe it's because the number of students are not that big. And about the teaching technical assistant, and the red ones are the teachers who said it is needed to be hired. and the green ones are we do have now, and the black ones said they don't need it at all. And about the time, enough is more than 50% and not enough are like this, but this can be solved, just manage, just like solving the rest of the problem. It's not a big deal, it's quite manageable and doable. And as you can see from the previous slides, the lab situation is quite poor to do proper experiments. So we have asked the teachers how to deal with this situation and about their plan B and what are they. And look at this. This black one is the total number of teachers in the province, and the pink ones are teachers who show experiment to their students from the internet, because there's no way to do a science experiment. And the green one, over 50%, almost 60%, they buy DIY things to do simple demonstration, and the money comes from the teacher's pocket. It's so poor situation, and this part means try my best to explain verbally and illustrate it on the blackboard. And the lowest part of teachers said they buy DIY things to do simple demonstration, and the money comes from the school budget. And about the internet website, physics teachers most likely visit to FED, WASCAC, YouTube, and produce ND content. It's a Mongolian site, I guess, and Moza Web and Khan Academy and some Russian website. And about the chemistry, it's more YouTube and Crocodile and one Mongolian guide for teachers and FED, Khan Academy and Chemistry Fund, etc. Yeah. Oh, I'm sorry. And about the capital city, the result was almost the same. Now, from this slide, so few teachers got the help from the school, from the school budget. So we asked teachers, what if there are something needed to be purchased for the class? Like, whom do you ask for help? And they said, for example, in the province, most of them go to their school principal. And another response was they have no idea whom I should contact. And the third one was school manager and education bureau specialist, education bureau head, and some few teachers asked the parents help for it. And however, in the capital city, they don't usually work closely with the education bureau specialist and head as close as the province, but rather with the principal or manager of the school. Yeah. And for the last part, we asked if they prepare their students for Olympiad. And in provinces, results are like this for the rest of the teachers. It's for chemistry and it's for physics. And here the red ones are teachers who don't prepare their students for Olympiad, and yellow ones are the teachers who don't have chance to do experiment, so only like theoretically prepare their students. And the green ones are the teachers who do prepare their students with both theoretical tasks and experiments properly, which means properly. And these teachers are the teachers who didn't receive the investment, and those are the teachers who received the investment in those years. And as you can see from here, the number of teachers prepared their students properly is increased more than 2 times. And the same thing happened with the physics teachers in the province and also in the capital city. And chemistry teacher, physics teacher, chemistry teachers started to doing experiments, and also the physics teachers. And yeah. Okay, to wrap it up, besides the scrappy and randomly distributed investment, the number of teachers and specialists for specific subject is needed to be reconsidered, and the lack of organization and management structure results in slow and incomplete data collection, and it's impossible to reach like 100% perfect. And there are a lot of same level of schools have totally different lab infrastructure, results in inequity. And about the investments, the reason among the teachers who don't use the equipment, the lack of sufficiency and time are dominating. And in addition to the main equipment and the furniture, chemistry teachers would like to have more glassware, especially those are fragile, more frequently. And in addition to the fact that it has never been included in the budget, the basic mechanism of purchasing and extinguishing the chemicals has not officially developed yet. And the other essentials for the equipment have always been overlooked, and also the absence of the particular room, aka laboratory, decreases the lifetime of the equipment, and even some equipments are just gone, just lost. And therefore, to conclude, we must let the policymakers be aware of the possible outcome and current demand of these issues regarding the science laboratory, and we have to optimize the organizational structure of the Education Bureau and for better and more open source as well as rapid responses. And we have to invest more to establish science laboratories in schools and provide essential equipment and supplies without leaving anything and anyone out. And the budget for other supplies which are quickly run out of time must be clearly included in the certain budget. And in addition to the provision of the laboratory supplies and equipment, the other factors must be taken into account by looking in the bigger picture. And therefore, our team has come up with an idea as a solution for these issues, and it's a national program to establish science hub in every unit, and the Minister of Education and Science Ministry should stand in forefront and lead this program. And it has four main objectives as follows. And the first one and the foremost step should be establishing laboratories and with a decent amount of supplies. And in addition to the classic laboratory, we have to form an open, modern, and coherent networking system, and they will be holding after-school activities, providing students opportunities for science projects, and also organizing competitions, and most importantly, event for major guidance, because high school students, they have most likely have no idea about what kind of majors are in demand and who they can be, what are the options, something like that. And next interesting one is the government must be supporting local startups who want to publish experimental guides in Mongolian language and create video content about how to do experiment and design DIY laboratory kits and developing virtual laboratory contents. And last and most important one is, at the present of time, regardless of our inexperience, we have to establish national factory to start making our simple supplies for the school, such as widely used geometrical models, simple experimental kit for elementary and middle school maybe, and for mostly for like science classes and so on. Yeah, that's the idea, and thank you for your attention, and hope you can give your feedback to us. And that was the report for the Mongolian current situation, and we will be more than grateful to hear your feedback and ideas on this issue, and thank you again.